An integer between 1,000 and 9,999 inclusive is chosen at random. What is the probability that it is an odd integer whose digits are all distinct? Okay. So that's going to be So these are, this is it for 1,000 to 1,099. See if I notice a pattern. Yeah, then we wouldn't be able to do 1,100, but we could do then 1, 2, and so forth. So inclusive, there are, including 1,000, the number of digits here, it's 9,000. How many we get here? 28, rather one. Let's actually count this. Yep, 28. And I imagine there are going to be 28 here. Yeah, then the 1300 to 1399. Yeah, okay. Let's just plan this out. So 1000. There's 0 here. 28 should be 28 again here. 28 here. So this is going to be it's 8 times 28 of these. But then we're going all the way. We're doing starting with a 1, then we do 2000 to 2099, and same all the way to 9000 to rather 2999, 9000 to 9999. So that's 8 times 28 in all of these. So 8 times 28, and there are 9 of these. So it's 9 times 8 times 28, which is 72 times 28. And multiply those. I mean, this is, yeah, 28 times 72. I mean, total number of these digits is going to be 9,000. So it's just this over 9,000. Can simplify 28 times 72. This is kind of like 90 times 100. And figuring out what we can cancel here. I mean, 9 times 8, this can go to an 8. A 9 gets, or rather, no, this is, so cancel out a 9, this is a 10. 9 times 8, this is an 8. 4 out of here, if we take a 4 out of here, that's 25. Divide this by 2, that's a 5. Divide this by 2, that's a 4. So 4 times 7 over 25 times 5, 28 over 125. $28 over 125. All right, slowing this, maybe going back a bit. So we did have this 7. We cancel the 4 in there. That's 25. We did cancel the 9 there. So we're left with 8. And then we have the 10 here. 56 over 250. Wonder if I'm missing like an intricacy of one of these cases, because I think it's close. The 12, 13. I mean, when I keep going, so 1203, 1235. I mean, when I have, in the case of, let's say an odd integer is in the hundreds place, so 1300 to 1399, does this limit the options we have? So 1301, yeah, 2 odd integers are used up here, so we have to skip to 1305. I think that's it. 130. Yeah, we can't do 1301, 1307, 1309. So in these cases, we have to consider that. In these, we are dealing with even digits in the tens. So let's actually, so 13, yeah, we have to go 1305, 1307, 1309. Yeah, and we keep going here. Yeah, I think this is it. So there are going to be less cases than we initially considered. Okay, so 1, 2, 3, 4. There are 20 here. $21 actually. 1. Yeah, 21. So in those cases, 21, yeah. So analyzing this, we can go through each one. So the 1,000 to 1,099, they're 28. From, yeah, one, yeah, okay. The nuance is this. They're going to be 28 again, but then when we have an odd integer here, it's going to be 21. It alternates 28, 21, 28, 21. I mean, I bet it's even going to be different. Yeah, sheesh. This problem is more complicated. I've made it here. Because then we need to consider when this digit is even too. Hmm. So with this, how many 28s there? 1, 2, 3, 4, 5. So 28 times 5. And then it's 21, 21, 1, 2, 3, 4, 21 times 4. So with this, 140 plus 84 is 224 here. But in the case when we have, like, for example, 2000 to 2099, that's going to be, yeah, what we can do is 2000. And could we do 4 in a, So 30 out of this. There's a lot of stuff here. Probably a lot more work than I'm doing, so we'll call it unfinished. Returning to this one after some time away. So, thinking about this, we can think about, so these are it's going to be a 4-digit number. An odd integer whose digits are all distinct. So for this to be an odd integer, the options for this, for the units digit, is 1, 3, 5, 7, and 9. So there are 5 options for that. And to be clear, the number of total options for this, when we do this probability, are going to be, there are number of total numbers here are, this could be either a 1 or a 9. The number is 1 through 9. Then it could be 0 through 9. 0 through 9 again. And then last digit, 0 through 9 again. So number of numbers here, this is 9,000. So yeah, going back to, in this case, 5 in the units digit. And then there are 5 options here. The number of options here are going to be, we need to exclude this number, but we should have nine options for that. There are 10 options. We're excluding this. And here, there are going to be, we exclude these 2 numbers, but there are 8 options. And then this number is excluding 0. And it's excluding these 3. So there's 6 options here. So this is going to be 6. So I think the number of odd integers whose digits are all distinct, I think it's going to be 6 times this. We can cancel. Cancel out a 2 here. And cancel out a 2 here. So we've got 12 over 50. Yeah, wonder if I'm slightly off here. Yeah, wonder if it was the way in which I did this. What if we consider the opposite? An even integer. So this could end then in Okay, I don't know if we... What if we go the other way? So there are 9 options here. Then everything except that, except this number. There'd be 9 options here. Then here there'd be 8 options. And then this would be let's just think for a sec. Let's consider if it ends in 1. So if it ends in 1, there's a 1 here. Then there are, starting here, there are, yeah, not that and not 0, 8 options here. Then this number can't be that or that. But it could be 0, whereas this one can't be 0. So there are 8 options here. And then this number just can't be this number, that number, that number. So there's 7 options here. And then this would be the case then for 3, 5, 7, 9. So times 5. So how does this number work over this? Two down here. Okay. So 16 times 7. Oh no, didn't see the 9. That is an option here. So think, what did I do differently between these to allow me to get this? So it is true that there are 5 options. Yeah, I don't know. I think it was helpful considering if it ends in 1, this is the case. So we can have, yeah, if it ends in 1, then, I mean, and even reversing this, let's say this is 1. What if we started here? What was it about starting in this place? Yeah, I want to understand this a bit more. Like I did get an answer, but yeah, why is it about starting in the, I guess, the thousandth digit? Does that make the difference? Well, I guess it's just something that we know. Maybe if we think about it like this. So this digit can't be what that is, can't be what that is, can't be what that is. So there are 7 options for it. And then this digit can't be what that is, can't be what that is, can't be what that is. Yeah, I don't know. Yeah, why is it that... So very clearly, this cannot be 0 and this can't be 1. So there are 8 options. If we'd started here, this cannot be 1. Yeah, this cannot be 1. This cannot be 9 or 1. This cannot be 8, 9, 1, or 0. But this isn't... Yeah, I think it's that this, when we select this digit, well, what if one of these is 0? We didn't factor that in. So that's why I think we've set that. We have to start with that. Yeah, I think 56 over 225. I don't know if that's the right answer, but that's what I'll say that's my answer, 56 over 225. Choice B is correct.